kenapa kita harus berubah?
Indonesia terus bergerak cepat bersama roda ekonomi dunia. Sekarang saatnya beradaptasi, eranya bertransformasi. Tapi, kenapa masih ada yang ragu?
Digital, bukannya ribet ya?
Emang usaha saya bisa diapain lagi pakai digital?
Sinkronisasi data pakai digital. Aman kah?
Untuk terus melesat, jadilah bagian dari perubahan sekarang juga. Saatnya bisnis Anda melesat bersama Telkomsel My Business. Partner terpercaya dengan rangkaian solusi digital. Untuk menunjang segala kebutuhan bisnis Anda menuju pencapaian yang lebih baik. Karena sekarang saatnya melesat.
Okay, I think we need to start since we're already behind 15 minutes. Good morning, good afternoon, and good evening, honorable speakers and also the distinguished attendees. Thank you for joining this breakout session 04 of the second day of IEECCE 2021 conference. On this session, we will discuss various innovation to improve energy efficiency and conservation in the building sector. First of all, I would like to introduce myself. My name is Dewi Larasati from Green Building Research Center, School of Architecture, Planning and Policy Development, ITB. I will be the moderator of this session. I'm sure this session will be very interesting since we have speakers are experienced experts. In this panel session, we have 5 outstanding speakers who will share their experiences in increasing efficiency and conservation of energy use in the building. However, this session is scheduled from 15:30 to 17 p.m. Jakarta time, but we already passed 15 minutes from the set schedule. So therefore, its speaker will be given only 10 minutes to deliver their presentation. Then we will continue the session with the discussion for approximately 20 minutes. During the presentation, the attendees are welcome to ask questions via the Q&A button. So I would like to introduce the speakers of this session who are Pak Wirawan. Hai Pak Wirawan.
Hai,
Halo.
Good afternoon Bu. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Pak Wirawan is Director of PGB Investment, and also the second speakers we have Louis Potok. Hello Louis.
Hello, everyone.
He is CEO of Riculit. And then the third speakers we have Matthew Snyder from our Ecolation Sweden. Hello, Matt.
Hello.
And then the fourth speaker we have Takahiro Asahi-san. Konnichiwa.
Konnichiwa.
And then last but not least we have Pak Ray Lianto from ABB Sakti.
Hello.
So, hello, Pak Ray. So we will start the presentation from the first speaker. The first speaker is Pak Wirawan. He is Operation Director of PT PGB Investment. He has 11 years of work experience in mechanical engineering, especially asset management, on work planning and control, outage management, failure mode effect analysis, and project manager of overall and also has 5 years experience on renewable energy, especially for photovoltaic related work. Pak Wirawan will share with us the information about the prospects of floating solar power system in Indonesia. Pak Wirawan, time and the screen is yours, but I will give a sign if you have 3 minutes left.
Oke,
Silakan Pak Wirawan.
terima kasih. Good afternoon, to the program scientist, moderator, all speakers, and also all the participants of the third Indonesia Energy Efficiency and Conservation and Exhibition. I would like to share my presentation. So, Ibu Dewi, is it already on screen?
Oke,
I'd
Pak.
like to start.
Very clear.
First of all, I would like to thanks to the committee to give us the opportunity to share our experience about the prospects of the floating solar PV in Indonesia. And then I would like to introduce, my name is Wirawan. I'm from the PGB Investasi, and I would like to tell a little bit about the PGB Investasi. PGB Investasi is actually a subsidiary of the PT Pembangkitan Jawa Bali, PGB, and PGB itself is a subsidiary of the PT PLN Persero. Our main business is IPP, or Independent Power Producer Developer. And right now we have 4 projects. The first project is a coal power plant with ultra supercritical technology in Banten, 2 times 1,000 megawatt. It's already commercial operation date. And the second one is the Batangtoru hydroelectric power plant in North Sumatra. The total capacity is 514 megawatts. And then the third one is the Sumbakso coal power plant, mine mounts. And the last one is the floating PV in Cirata, 145 megawatt AC in West Java in Cirata. So the slide will be, the common question is come to us, why a floating PV? At least there are secretions why Indonesia nowadays eager to develop the floating PV. The number one is a simplified land acquisition, because in Indonesia, the most challenge is the land acquisition. By utilize the water bodies, we can simplify land acquisition. And in the next slide, I will explain furthermore about the opportunity of usage of the water bodies in Indonesia. The second reason is the increased energy output. In some journal stated that the floating PV will give increase 5 until 7% of energy output due to the lower temperature in the water compared to the PV rooftop or also the ground mounted. The number 3 is the floating PV have decreased the evaporation, means that we conserve the water and conserve the energy, because in our project in Cirata, the PV and hydro power plant, we combine it together. So we call it, this is the best combination, because we conserve the water, and also the second one is the intermittency of the output of the PV will be stabilized by the hydro power plant, which we know that the output of the hydro power plant have the ramp up and ramp down the quick way to up and down the power. So number 5, the reason is Indonesia has many lakes and reservoir. I will furthermore explain in the next slide. And the last one is the suppressed algae growth due to the coverage of the PV module in the reservoir or lake. And then I will continue to the next slide is the challenge in the development of the floating PV in Indonesia. Number 1, actually, this is a new technology or pioneer. Means that there are some aspects that we should have the risk mitigation on this project. The second one is the investment cost, that we think that it is relative higher than compared to the ground mounted. And the number 3 in Indonesia, the permits and environment is very challenging one, including the environment and social impact analysis should be done. And there is many permits that we should done before we start the project. Then number 4 is the operation and maintenance, that we think that it is relatively complex compared to the ground mounted. And the last challenge in development of the floating PV in Indonesia is actually for the regulation and also the dam safety, because we should perform the dam safety analysis before we construct the floating PV. I would like to explain furthermore in the next slide, in the regulation slides. I will continue in the next slide. It is only just for overview about the opportunity or potential reservoir for floating PV in the world. In the data, we can see that there are more than 400,000 square kilometers of the man-made reservoir in the world, this one. And if the usage is of 1% from the surface area available, this one, we will give more than 4,000 gigawatt peak installed capacity, and will give the energy output around 500,000 gigawatt hour annually. If we increase 5%, the total PV installation will be more than 2,000 gigawatt peak, and will be, the energy will be around 2 million gigawatt hour yearly. This is the illustration of the opportunity or the potential reservoir in the world. And the China still is the largest PV floating developer in the world, followed by Japan, Korea, and England. And recently in Southeast Asia, for example, Vietnam, Malaysia, and Singapore also developed the floating PV. And this figure is only shows the distribution of the floating PV plants according to the size. We can see that actually the floating PV has become the new trend in the world, with the total capacity around 1,300 megawatt peak and increasing over years, while the floating PV project size above 50 megawatt is just only 13 projects in the world. It means that's still rare. And China still the largest PV floating developer in the world. What about the cost of the floating PV? The real data based on the journal, the real data related to the capital cost and operating cost still relatively difficult to obtain. In addition, floating PV capacity above 15 megawatt is only about 13 projects in the world. So the general published data is usually indicative, so it is difficult to make comparisons. The unique data such as a grid connection cost and then land lease, import tax and duties, and also others, difficult to obtain and difficult to compare. This is only this figure about the cost of floating PV in the world is around 0.8 until $1.2 per watt peaks. What about Indonesia? Regulation floating PV in Indonesia actually in a Public Works and Housing Ministry Regulation number 6 year 2020 Kementerian PUPR concerning amendment to the last regulation of the Minister of the Public Works and Public Housing number 27 year 2050 concerning dams. In the article 105, actually utilization of the space in reservoir areas can only be carried out for A, tourism activities, B, sport activities, C, fisheries cultivation, and the last one, Ministry of Public Works at one point is floating solar PV. So it becomes formal, legal to build the floating solar PV power plant in Indonesia. But again, still the government still limited the size of the floating power plant. Its maximum is 5% of the surface area of the reservoir at the normal water level. Means that the government still limit the 5% from the total area, surface area of the reservoir itself. And then this is a potential lake or reservoir, man-made water bodies for the floating PV in Indonesia. The totally, according to the Directorate General Water Resources, Ministry of PUPR or Public Works and Housing, the potential is around 28,000 megawatt in 28 locations, is spread into the reservoir and also the lake. And the left side is the data, the total potential in the hydropower plant, means that the reservoir or the lake that located near to the hydropower plant like a Cirata. So this is the spread of the location and also the size of the floating PV in Indonesia. For example, Sumatra, 7,000 megawatt in 3 locations. Jawa, Madura, Bali is around 2,000 megawatt in that location. Kalimantan, 1 location. Sulawesi, 6 location. And the rest, Maluku, Papua, and Nusa Tenggara is 5 location, which total capacity is around 40 megawatt peak. And then this is the IEECCE studies, Institute for Essential Service Reform, that there are 10 potential reservoirs that can be used for floating PV. Most of them is also for the hydropower plant in Central Java. This is Central Java. This is the spread of the location and also the size of the potential of the floating PV in Central Java. And I have the 2 last slides is the overview of the floating PV Cirata in our project 145 megawatt AC located in a Cirata reservoir and near the hydropower electric power plant Cirata. And it is located in the cascade of the Citarum River. The upstream is Saguling Dam, and the second one in the middle is a Cirata Dam, and the last one is a Juanda Dam. So this is just illustrative pictures of the floating PV in Cirata. The parties is two entity from the PGBI, and also for the Master United Arab Emirates, with the participation interest in the GV is 51% from the PGBI and Master 49%. Installed capacity is 145 megawatt AC. Location I already mentioned earlier in the Cirata Hydropower Reservoir, owned by PT PGB or Jawa Bali, and with land requirement approximately 2,040 hectares. It means that if we compare to the total area of reservoir, is only occupied 3.8% of the total area, because the Cirata Lake is more than 6,000 hectares square. And then transmission line is transmitted through the 150 kV, about 3.8 kilometer circuit to the Cirata high voltage substation. The scheme is build, operate, and transfer, and COD or commercial operating date estimation is November 2020. The tariff is considered low, is only 5.8 US cent per kilowatt hours. And this is the milestone that we already achieved, the PPA signing January 2020. And then financing date is already achieved on 17 May 2021, and COD will be expected on 17 November 2020, or 80 months since FD itself. And this one is illustration about the floating PV Cirata. This is the water, and then we call it this floating system. And then above the floating system is solar modules, PV modules, and also combiner box. And also this is mooring and anchoring. The depth of Cirata's lakes around 80 until 90 meters. And then after this combiner box, and then this is a DC side, and then goes to the inverter. Inverter is convert from the DC to the AC, and then we have step up transformer, and then delivered to the transmission line. This is the picture of the construction phase, and this is the picture of the operation and maintenance phase. So I think Ibu Dewi, this is that's all from my presentation. We do hope that this material fruitful or meaningful for all of us. Thank you very much. I will get back the time.
Thank you very much, Pak Gunawan. Presentation. I have some questions regarding the presentation. Is it okay for me to ask you?
Yeah, please, Ibu Dewi, please, Ibu.
Regarding to the environmental impact, is it any study has been conducted regarding the impact of installing floating PV on the water bodies or reservoir area? And the
Yes,
second question,
we have already had the AMDAL and also Asia Environment Social Impact Analysis. That actually this is requirement from our lenders, Ibu, because our lenders very strict. So every single study, especially for the environment, should be done before they will give us the the credit. Yeah, this is
okay. Can I have another question? Actually, I have 4 questions for you.
Please, please.
Can floating PV also be implemented in the marine area or sea water area?
Yeah, in the few studies in China, they already start to put the floating PV in the not offshore but near shore, because in near shore the wave is not so wavy, but also the difficulties is on the anchoring and mooring itself, Ibu. So in near shore the depth is considered not too deep, but in the offshore usually is deep. So it will be impact to the financial perspective, Bu Dewi. But in technically, we can implement to the near shore.
Yeah, since we have a lot of sea area, ya Pak ya.
Yes, of course, Bu.
And the last one is any program or effort in order to increase the TKDN ya, tingkat komponen dalam
local content, yeah.
And the development of PV product in Indonesia.
Yes, in our project, we comply the local content or TKDN as stated in the Ministry of Perindustrian is 40% from the modules, PV modules, and also the floater. And how we achieve that? We cooperate with the local manufacturers to make this PV module in order to. Pardon me?
Where is it? In Jawa or other?
In Jawa, in Bandung. So we have the EPC or engineering procurement construction, and they already pointed the module from the China, the design from the China, but the location of the manufacturer will be in Indonesia. That totally the local content will be achieved to around 40%.
Okay, thank you very much, Pak Gunawan. Very clear explanation. So we'll let's move to the second speaker. Okay.
Thank you.
Okay, thank you, Pak ya. Nanti for the attenders are welcome to ask question by push the Q&A button and you can write the question for Pak Wirawan. And for the second speaker, I would like to ask Louis as the second speaker. I also want to introduce you, Louis. Louis is the founder of and CEO of Recoolite, which is solving the world refrigerant emissions. He has spent over a decade at several startup companies and also non-profit solving socially impactful problems around the world, and has a background in consumer software, data science, behavioral economics, and international development. Mr. Potok holds a degree in economics from the University of Chicago, and he is certified by the United States Environmental Protection Agency as an HVAC technician. Louis will share with us the idea of cooling refrigerant recovery. Mr. Potok, time and the screen is yours, and I will give a sign if you have 3 minutes left.
Thank you so much. Jeff, are you able to see my screen? The presentation?
Yes.
Okay, fantastic. So as I was introduced, I'm Louis Potok. I am the founder and CEO of IEECCCE, and I will be talking today about solving the refrigerant problem in Indonesia. This is a topic that is not discussed often enough, so I will begin with some basics for those who are not aware. And if you are already aware of this issue, I appreciate your patience. So we know that cooling in all of its forms is critical to modern life. Air conditioning, and I think that is of the most interest to this buildings topic, but refrigeration as well. And we have seen for vaccines as well, the cold chain is incredibly important. And we need cooling to have the standard of living that we expect in the modern world. Demand for cooling is also growing fast around the world as places get hotter due to climate change and as economic development occurs and the world gets richer. More and more people are able to afford air conditioning. And of course, this is something that everybody wants to buy, especially in countries that have high ambient temperatures. A little bit of the scientific and technical background is that air conditioning works using chemicals called refrigerants, which are pumped around from one side to the other and are the medium of heat exchange. I will not go into any more detail about the inner workings of air conditioners. But the problem with these refrigerants is that they cause climate change. So normally when we discuss climate change, we talk about carbon dioxide and carbon emissions, but refrigerants that are commonly in use like R134A, R22, and R410A are much worse than carbon dioxide, between 1,000 and 2,000 times worse on a kilo for kilogram basis. So for example, 1 kilogram of R410A, which is about the amount in a household mini split unit, is equivalent in how bad it is to burning 850 liters of gasoline. So very, very powerful, even in very small quantities. And it is because of this, for this reason, that Project Drawdown, which is an international research group, rated refrigerant management and proper disposal as the world's #1 climate opportunity, the largest chance that we have to mitigate climate change and the damage that it will cause to the world and its environment. So this is where IEECCCE comes in. What is needed here? Right now, in Indonesia, 4% of all emissions are only from these high GWP refrigerants. And the AC sector, as we know, is growing quickly, over 5% per year. The Ministry of Environment is developing a plan to phase out and manage these refrigerants, but private action is also needed. Private action can move faster and solve certain problems that can be challenging to solve through regulation. Most of these refrigerants are actually emitted when devices reach end of life. So an old air conditioner is thrown out, it is scrapped, maybe it is replaced with a new one, and the gas is simply pumped into the atmosphere. So these refrigerants need to be not emitted, they need to be collected and destroyed. And IEECCCE is here to help solve that problem, which is what I'll discuss over the next few minutes. Now, this is not IEECCCE coming in and telling a bunch of people in Indonesia what is needed and how to do it. There's already a great deal of expertise in Indonesia between the AC technicians and their membership associations, the green building initiatives, the manufacturers and distributors of air conditioning, universities and academics like ITB, waste management companies, government, international agencies, engineering services. All of this expertise is what is needed, and we are really only here to build a community out of these different groups to work together to solve this problem. So all of these different groups, and green buildings is not listed here, but it should be, will need to come together and solve this problem as a group. And so IEECCCE's role is to help bring together this community and sustain it. And when we think about what is needed and how we can support this activity, we look at past programs that have been tried in Indonesia. often funded through multilateral organizations or by donors. And they've had challenges. Our approach is we believe that economic incentives are required. If we think about the technicians who will actually be performing the recovery and adopting sustainable practices, we know that even if they are motivated out of their own desire for environmentalism to perform these activities, they may not want to pay extra money in order to do the right thing, to do the sustainable practice. So IEECCE is actually providing funding and support for recovery of these refrigerants and also their sustainable management. Our economic model that allows us to do this is that we manage and oversee this whole chain of refrigerant from the end-of-life devices, from retrofits, from stockpiles of old refrigerant that may still exist. It is recovered and then either destroyed or purified and reused. We perform data collection and tracking using our software to make sure that we have a full and transparent and trustworthy set of practices through that process. And we then generate carbon offsets, which are sold to US companies, which is what allows us to pay for these activities to be done in Indonesia. So our model does not require any environmental motivation in Indonesia. We know that that can be challenging. It can be a difficult way for projects to get done. We require economic incentives, and our business model allows us to do that. We are just beginning our work in Indonesia. We've spent the last 6 months building partnerships here and performing research on the industry. And we are launching some pilots early in the next few months with a goal to destroy a certain amount of refrigerant by the end of the year. We then hope to build on the success of those pilots next year to expand both across Java from our base in Jakarta and then across the rest of Indonesia as well. As we know, Indonesia can be a challenging place for logistics because of all the islands. So we're starting in Jakarta and in Java where this work will be easiest. Our team, so as I mentioned, I'm the founder and CEO. We are building an office in Indonesia as well, starting with these two very experienced and skilled engineers and managers to build out that team. And we hope to have a presence in Indonesia sustained by our business model for many years to come as this ecosystem and community that I have described develops and becomes more in place. So we are looking right now for partners and supporters to join our movement. If any sort of green building initiative, any air conditioning manufacturer or distributor, anyone who is involved with air conditioning systems at any point in their life has a role to play in this fight that we have to prevent the emission of these harmful refrigerants. And so we are looking to speak with as many people as we can across the industry. And our contact information is here. You can reach out to me or to the head of our Indonesia office, Jessica Dama. And thank you so much for your time. And I look forward to both the questions from the audience and hopefully to follow-ups about potential collaborations that may come out of this session. Thank you so much.
Thank you for your presentation. Okay. I would like to ask you some questions based on your presentation. Is it okay?
Yes, of course.
I have 3 questions actually. First, regarding the buyback used refrigerant. Actually, I am curious, why do you buy the used refrigerant and how do you utilize the used refrigerant? And the second one, what are the obstacles that arise in the building partnership ecosystem in the development of refrigerant recovery systems? And the last question is, what kind of economic incentives do you propose regarding refrigerant management system in Indonesia?
Wonderful. Yeah, thank you. Thank you. Fantastic questions. So I will try to answer them in order, even though there are some connections between the questions. So the buyback program, the idea of that is that there are situations where technicians or engineering firms will recover refrigerant and then they will have it in these cylinders that they have no way to process. Their only option is either to hold it and store it themselves or to pump it out into the atmosphere so that they can reuse the cylinder. And so our buyback program is meant to solve that problem. So we take their full cylinders, vacuum pump out the refrigerant into our own storage tanks, and then return the empty cylinders to the client so they can be reused. We then take that refrigerant to be destroyed with our waste management partners. So the buyback, it's similar to something that you might see with e-waste, where we are just trying to prevent it from being released to the environment, and then we process it on our side. You asked also about so maybe I'll go out of order and talk about the economic incentives in your third question, because this buyback program is one of those. Another type of economic incentive that we can offer, some technicians in Indonesia do not have the tools or the equipment to perform refrigerant recovery. And so we can provide that for them, and instead of them buying it themselves, which reduces the cost to the technician. We can also provide some of the transportation that is required for the refrigerant. So by paying for that, we reduce the economic barrier and burden to the technicians and the other firms in the market, which helps create the incentive for them. We believe that these incentives are most important for the smaller technicians, the mom and pop, the small businesses, and that for larger companies, it's just a matter of them not having to pay for it. So it's free for them rather than a bonus, but yeah, we try to reduce the costs and add an incentive to everyone who is involved in this community. Which brings us to your second question, which I'll answer last, about the challenges of creating this ecosystem. I think that one challenge is, to be perfectly honest, skepticism about this kind of program. Because as I mentioned, there have been similar programs in Indonesia in the past. And in my opinion, they were funded by donors or by other kinds of agencies to be only a short-term project and to perhaps perform trainings, perhaps distribute equipment on a one-time basis, but they were not committed to ongoing operations and ongoing activities for many years, which we believe is required to solve this problem. So what we are seeing with our partners now is that our commitment to staying here in Indonesia and working here in the long term together, hand in hand, to solve these problems is what will allow us to overcome this challenge and skepticism and build the community that can help solve this problem together.
Okay, thank you very much, Luis, for your explanation and also your commitment to these problems in Indonesia. Okay, thank you very much. Let's move to the third speaker. We have Matthew Snyder from our Equation Sweden. I would like to introduce you, Matt. Matt is a product and design manager that has worked in taking a product into package concept in North America, Europe, and Asia. He has previously worked in the athletic consumer goods segment, but grew tired of working on large amounts of consumption. He is also co-founder of our Equation Sweden. Matthew will share the concept of using agricultural waste into building material. Mr. Steiner, time and screen is yours, and I will give a sign if you have 3 minutes left.
Okay, great. Thank you. Yes, as was mentioned, I am Matt Schneider with our Equation. We are very recent to the Indonesian marketplace. One thing we saw when we were introduced to Indonesia by our friends within Business Sweden and the Energy Ministry of Sweden is that we saw tremendous potential and fit here. When we go through this, I think you will as well. So my first slide here is an introduction from the UN looking into the developing countries within what is needed in order for rapid, successful industrialization. And what they were going and looking at was, what are countries that don't have the wood production but can have other materials where they're using these materials for vital buildings. Once we follow and look into the bottom here, the key thing that was considered was that we don't look at these as just isolated meetings, but a starting point for serious measures within the scope and technical assistance programs. This was something that was put forward and that we, I think, all realize that we can't just have these meetings, but we need to continue to strive to do better after the meeting. So that brings us to our mission. And our mission is to accelerate the circular construction industry through turning agricultural waste into sustainable building material. Now, what we're doing is creating a circular construction by bringing the factory concept to the local market. So this is looking at these agricultural wastes and taking them from a waste to a resource. And that's something that was done within the energy industry in the last 30, 40 years of looking and realizing that there's so much wind and solar power out there. Why don't we go out and take what there is of waste in the fields and bring that field waste into and help us build instead of mining for materials? That brings us to cement. Cement is one of the most common construction materials and represents 6% of the carbon emissions. Now, this is something along with steel and aluminum that we look at 22.7% of carbon emissions around the world. And we need to look at these embodied carbons as something that this is a one-time cost or one-time emissions just because we design and come up with a building construction that we're not able to eliminate those. So really in thinking of how we can design and adapt materials for emissions for a better world for the future. The next step of how we go and look into things is by looking at agricultural burning and of looking at black carbons. And these are more intense than CO2 and causing a much larger impact into the weather patterns of the world with the ability to affect cloud formations, as well as getting in snow and ice particles, thus causing a larger glacial melt. So that's where we come in, and we think we can be one of many solutions that helps go from burning this waste material to turning the waste material into a resource for localized production. So we are a construction material, and we looked at that and of working with farmers on this, and not just us, but paper products, bioplastics can be made out of this, as well as you can look at energy. That's one of the things that's mainly discussed when looking at bio waste. So that's where we've worked with Business Sweden already, and then in looking into Indonesia. The first looking into the island of Java, where just under 10 million tons of rice are produced each year. That's 12 to 15 tons per hectare are harvested. And we have already found that the majority of farmers would be very interested in selling their material versus burning this. Today, 76% do burn their material. So this can be a very quick, cost-effective approach to changing carbon emissions in Indonesia today. When we look at the market size within Indonesia, we know that it's growing quite drastically in terms of the urbanization and household markets. So for one, in other places, we also look into gypsum. Gypsum is not as large of a product in Indonesia. However, cement and cement bricks is a major building material, not just in Indonesia, but also in China and Thailand as well. So that's where we get into our micro factory network. And within that, what we do is bring the factory concept into the localized environment. From there, we're able to work with the farmers of taking the material into the factory, pressing the waste material into boards, which then we're able to build wall systems. Within those wall systems that are our concept and designs, we take and make those into homes. There is no water needed. Our machines also run off, only require 150 kilowatt hours to make, as well as, since we're making these all locally, we can provide them on specific islands as well to provide local employment too, and then keep the costs economical for the local builders as well, and making sure that people are able to afford this housing without subsidies. So this is just a brief example of what our actual machine to make just the board, and then we get into our process of building walls, but taking a bale all the way and having it be cleaned and then go through within pressing along and cooling down to finally be cut in terms of where it will be processed. This is a photo of the bales going through and the amount of material that we can utilize. Just of looking at 45 square meter homes, there are many, that's part of the Million Homes a Year program in Indonesia being built, trying to calculate that out. It'd be roughly 1,500 homes a year with one machine. So there is a considerably large amount of raw material that can be supplied here when we're looking at just under 30 million tons. So this shows where we have been working on projects all the way Estonia, England, Ireland, Australia, and Sweden, as well as the US. In the US, there were 2 banks that were built 10 kilometers apart with the same look on the outside. However, one utilized our material, the other utilized concrete and steel framing. When it was completed, ours ended up costing 20% less and is costing them 15% less in terms of energy use today.
Okay.
So I conclude back at this slide here done by the UN and thinking of this. Unfortunately, this was not worked on because this slide was actually done in 1974 by the UN. So we really look to take this over and not just investigate, but take this into action. Thank you.
Thank you, Matt, for your very interesting explanation. And we will have a question and answer in the end of the presentation. Please, Takahiro Asai-san, I would like to introduce you first. Asahi-san has 14 years experience in sales engineering background in electric and HVAC companies with emphasis in energy efficiency in the industry and commercial sectors. He was also in charge of HVAC system design for EE buildings, including zero energy building, design and implementation of industrial heat pumps, and also the development. Okay. Okay, I will continue. Currently, Mr. Asahi is a manager of International and Technical Research Department, Heat Pump and Thermal Storage Technology Center of Japan. Asahi-san will explain heat pump technologies key to energy efficiency improvement. Asahi-san, time and the screen is yours. I will give a sign if you have 1 minute left. Dozo.
Thank you for your introduction. And before starting, I'd like to show my appreciation in this great event, IEECCE 2021. And I'd like to thank all the staff as well. Thank you very much. And good morning, good afternoon, and good evening, everyone. Let me share my screen. I think not having to see people sleeping in front of me is one of the advantages of virtual conferences. So I hope you stay awake during my presentation. I'm Takahiro Asahi from Heat Pump and Thermal Storage Technology Center of Japan, HPTCJ. What I'm going to talk about is just heat pumps, and my main message is just please remember heat pumps. Don't forget about them. It's a very simple message, so please sit back, relax, and enjoy. Before talking about heat pumps, this is just a short introduction of who we are. I will enable laser pointer. We, HPTCJ, is involved in the promotion of technological advancement of heat pump and thermal storage systems. We were founded in 1986, consist of about 100 companies like utility companies and heat pump manufacturers and other organizations. We are active both domestically and internationally. As for international activities, we are involved in IEA's technology collaboration programs on heat pumping technologies and energy storage. We also have a network called Asian Heat Pump and Thermal Storage Technologies Network, and doing other promotions like I'm doing today. So, heat pumps are already well-known technology. Actually, the first heat pump appeared 160 years ago. But why am I talking about heat pumps today? As you know, commitments to net zero emissions 2050 have been made by many countries. I wrote here 123, but last week I read an article saying more than 130 countries have committed. On the Earth Day this year, Leaders Summit on Climate was held by the US, and there is an international discussion underway towards decarbonization involving many countries, including Indonesia. And IEA released the roadmap to net zero last month, as Mr. Fatih Birol, Executive Director of the IEA, said in yesterday's opening session. We can say world is going towards net zero emissions 2050. Also in Japan, net zero emission 2050 is stated in the amended Act on Promotion of Global Warming Countermeasures, which was enacted 3 weeks ago. In this context, heat pumps are attracting more and more interest as one of key technologies for net zero. Firstly, as energy efficient and eventually zero emission heating and cooling providers. In the IEA's roadmap, there are a lot of milestones related to heat pumps. No new sales of fossil fuel boilers in 2025. Net zero emissions electricity globally in 2040, and 50% of heating demand met by heat pumps in 2045. This is not a forecast, so I'm not saying here, I'm not talking about whether these will actually happen, but these are the milestones required to mitigate global warming in this roadmap. And secondly, as flexibility providers, IEA says heat pumps could and need to become flexibility providers. In the plenary session yesterday, Ms. Pauline Henriette from IEA mentioned the importance of flexibility, and she also said buildings could contribute to it. Ms. Maxine Jordan from IEA also mentioned the flexibility in the definition of a zero carbon ready building. Flexibility is an important aspect in the clean energy system where a lot of variable renewable energy like solar and wind exist. And I'd say heat pumps in buildings can play a role as flexibility providers. For someone new to heat pumps, I'd like to introduce you to them. Maybe most of you have at least one heat pump in your home, like air conditioner, refrigerator, and other appliances. It's a technology of carrying heat from one place to another, and it has two aspects. One is energy efficient heat supply. Heat pumps are basically carrying heat instead of generating it. And we can supply, let's say, 7 of heat out of 1 of input, though the value depends on the condition. So it's an effective, efficient way of heat supply. Another is renewable energy utilization. Heat pumps can extract heat from ambient air, water, or soil, and this heat can be seen as renewable energy, originally coming from the sun. So we can see heat pumps also as indirect use of solar energy. Though heat pumps have already proven successful in energy conservation, they will contribute to a lower carbon society along with the transition of the electricity sector. This chart shows how low carbon heat pumps will be compared to gas boilers. Horizontal axis represents emission factor of electricity, and vertical axis represents relative CO2 emissions with 1 for boilers. The black horizontal line here is the emission by gas boilers, which stays the same, of course, regardless of emission factor of electricity. And 5 blue lines represent heat pumps with different efficiencies, from 3 to 5 to 6. The stronger the line is, the higher the COP is. I assume that the boiler efficiency of 90% in this chart. I put emission factors of different countries and years on this chart. Indonesia's average is around 800, though I know it's different from province to province. In this case, COP of 4 is required to be lower carbon compared to gas boilers. The higher the COP is, the less CO2. This is the situation as of today. If the emission factor decreases in the future, if we go to the right, then heat pumps will emit less and less CO2. So if we install a heat pump today, in Indonesia, even if it's merely a bit better than a boiler, if the electricity is decarbonized, the heat pump we installed today will be cleaner and cleaner, even after the installation, without any additional countermeasures. While gas boilers continue to emit certain amount of CO2 during the lifetime of like 10 or 15 years, unless gas is also decarbonized. I hear from Indonesia recent news about future retiring of coal power plants and megawatts of renewable energy project like Cirata project by our first speaker, Wirawan. And if these actually happen, I believe the emission factors will go down and heat pumps will be more preferable for decarbonization. So,
Masai-san, you have 3 minutes left.
Okay, thank you for letting me know. So I talked about why heat pumps. I'd like to move on to its application and case studies. Heat pumps fit wide range of applications in terms of temperatures and capacity. And in a nutshell, it can be applied for a lot of applications in all sectors, residential, building, and industrial. This is the case of heat pump water heaters in a Z-Ready certified hospital. The concept is comfort and the use of passive and active energy efficient technologies. And heat pump water heaters contributed to 30% of energy reduction and cost saving as well. This is another case of heat pump water heaters. This time it's a hybrid system of boilers and heat pumps in an urban hotel. And the reduction was 18%. If the shift to complete heat pump system is difficult due to cost, space, or other reasons, you can also combine heat pumps with boilers. I showed you two cases of water heaters. In a tropical country like Indonesia, the heat load of hot water may not be so big. But I'm not talking about the proportion. Wherever combustion or direct electric heating exists, heat pumps can be a solution. So remember heat pumps. And because this is a building sector, I'll just talk a little about industrial. And heat pumps can be applied to industrial applications as well. And these are two typical applications of industrial heat pumps. First one is simultaneous cooling and heating. As you see on the left, coldness and heat was conventionally provided separately with coldness by chiller and heat by boiler. But heat pumps can simultaneously supply both cold and hot. And if this, in this case, it's very efficient. And I will show just one case of noodle factory. Noodle must be boiled and then cooled. Conventionally, noodle was boiled by boilers and then immediately cooled by chillers in the process next to it. And in this case, heat pumps are used to produce both heating and cooling. So like this case, if the heating and cooling are close to each other in terms of distance, timing, or amount, heat pumps can be an interesting solution. I'll skip this. So that's all my presentation. I hope you are still awake, and I'd be glad if you remember heat pumps as a key technology to decarbonization. Please don't forget them. We are collaborating with NASCE, and you can also go ahead and directly contact me for more information you might want. Terima kasih. Thank you for your attention. Back to moderator.
Thank you very much for your presentation. Okay, actually, I have question to be asked since the time limitation. I will ask after the last speaker presentation. So we move to the last presentation. Last but not least, our fifth speaker is Pak Ray Lianto from ABB Sakti Industry. I will explain Pak Ray profile. Ray Lianto is the sales manager of Motion PT ABB Sakti Industry. He is sales manager for drives products, motion business at PT ABB Sakti Industry. He has joined ABB for more than 9 years and has held different sales roles with focus on products and market segment in mining and minerals, HVAC, and also water and wastewater. He is responsible for marketing and sales and quality excellence. He works across a variety of channels, market segment, and also end users with a total of 15 years experience. Pak Ray will share idea on ultra low harmonic in building and improving power efficiency. Pak Ray, time and the screen is yours. Pak Ray, we cannot hear your voice.
Hello, everyone. Good one for this one. Can you see my screen for the moderator?
Yes.
Okay, so basically today we will discuss about the power quality in the buildings. And from yesterday presentation, we get explanation how inverter can do efficiency to the energy. But today we also want to understand in other side how about the power quality, because inverter is one of the non-linear load. Then the side effect is regarding for the power quality. So it will be creates harmonics, and this is also some explanation for the power quality. The power quality that actually it will be impact for like the voltage sake, voltage transient, some over voltage or under voltage. And the common way how to mitigate these problems is over dimension for the equipment or add external component to protect the sensitive device. So what with the power line harmonics, this is what we can see. This is the ideal waveform, which is we should get from the line. But unfortunately, in our line, if we are using, for example, non-load harmonic, non-linear load, like inverter, like for example LED or power bank or everything which are non-linear sinusoidal, then we'll create some emission from our power line. So this is the situation what we are facing today, and the implementation of inverter is more actually come from not from industry only, but also come from through the building segmentation also. So with the power line harmonic, basically we try to suppress the wave, which is not the fundamental wave. So basically this one, so the fundamental wave, then there are third harmonic, fifth harmonic, and we can calculate until 44th harmonics. Okay, so this is the power line harmonic. So the source is come from the inverter, and in all buildings there is many loads which generate harmonics. mostly the inverter who actually generate from the motor, because they are controlling motor. For example, in this picture is for the pump, then they will create harmonics to the line. Okay. Then why we do care how the impact of the power line harmonic? Actually, this also impact with the electronic sensitive to noise. For example, medical equipment in the building, airport navigation, security system, all the control system, computer. So it will be impact for the electronic sensitive noise. Also, our lighting system, power meters, and it will create some blinking if there are heavy power line harmonic in their network. Also, if for example, they have specific dedicated power plant, it will be impact from the generator or the electricity producer. So this is how bad the impact then for the harmonic system. So how to mitigate the harmonics, comparing the different solution, because today we have some of the solution for mitigate the harmonics. We can use reactor or chokes to filtering and suppress the harmonic system, especially in inverter. They have some of the inverter has already integrated for chokes or reactor, and also some can also add it as external equipment. The second one, you can use the passive filter for the capacitor. This is also the common ways and some economic ways to integrate it to the system. And the third one, using 12 or 18 or 24 pulse rectifier. This is a more customized solution from specific application and needs special transformer or active harmonic filter. Most of the time, this is really known as the best solution for reduce the harmonic. But there are some limitations like active harmonic filters and special transformer. You need to design specific for your system, and you will need help from the expertise to commissioning and do design for all of the things. And when for example the equipment is already breakdown and you need a special spare part, and of course it will be related of the downtime. So basically the customer have to invest some of the money for the spare part to make sure that the downtime is manageable. And the fourth one is the active rectifier. This is one we want to introduce for the ultra low harmonic drive, that you don't need to add to the special equipment to get best suppression for the harmonic. It's already integrated in our drive unit, and you don't need special commissioning. So you just do commissioning as a standard drive, but the emission is already manageable as good as you are using special transformer or the active low harmonic filter. Okay. Then this is how bad the harmonic will create. In this, if you are not using the mitigation, then the harmonic will come like 90% until 120% from fundamental waves. And when you are using the deselling chokes, some of the inverter supplier using this, you can suppress until 35 or until 45% of the harmonics. And if you add additional passive filter, and it will be suppressed from 5 until 15% of the current harmonic distortion. And you can also see the pulse for 18 pulse 5 to 10. And if you use active filter, you can suppress 5 until 10. For active rectifier, if you use ultra low harmonic drive, it can suppress 3 to 5%. According to IEECCE, we are trying to reach 5% typical harmonic distortion. It will be considered as a good harmonic mitigation. Okay. Then this is the pro con. Yeah.
Your time's 2 minutes left.
Okay. So the pro cons of acetylene reactor, as I mentioned also, it's already built in for the drive. And the contra is actually there are voltage drop because some power dissipation in here drop. Passive filter, it's easy to install, harmonic efficient, but of course there is a risk for actually resonance for multiply the filter. So every time you are install a different equipment, you have to review again how the passive filter do to effect the resonance. And the active filter, it is the best way in terms of the technical, of course, but the contra is the large size, you need the space and the cost, also the big cost in there. And in case if only one filter installed and they make failure, then it will be overloading the transformer. So it's only centralized solution. And the multiple rectifier, it's very specific for reduced harmonic, but of course it's also same with the active filter, it's large size and cost. And the last one, this is the drive for active rectifier. So this is the solution for built-in for drive and simple for cabling. And actually it's also below 5% according to IEEE standard. Then it's really easy to install and decentralized solution. Okay, and that is the last from my presentation.
Thank you very
Okay.
much. Okay.
Thank you.
Thank you, Pak Ray. Very interesting presentation. So all of the presenters have conveyed the ideas and innovation. It's time for us to move to the question and answer section. We have a question from the Q&A room from Erwin Salahuddin to Matthew from the Ecolution. Matt, can you hear me?
Yes.
Yes. The question is, what are the selective agriculture materials that can be used in your concept to make construction materials?
Yes, it's rice and both rice and wheat straw. So both of those have the properties within themselves to bond. So that's why rice is a very important piece to Indonesia. So.
Okay. Yeah, I would like to ask one question to you, Matt.
Yes.
Could you explain the roadmap of this idea, how this idea can be implemented widely in Indonesia?
Yes.
The low embodied energy sustainable materials.
I guess it's how wide we'd like to go. That's the thing. If we just want to look at if it's Java or if it's going, and really bringing this out because we have potential to where we could really take this from a roadmap within really 3 years' time. We could be able to have 20 machines up and going within Indonesia if we'd like, which that would be over 25,000 homes that could be built there. And then, then we could look even at, implementing things all the way within even building machines in Indonesia. So really the time horizon, it's just the start date that we focus on, and then how we can roll out in a rapid pace, because, Indonesia is building so many homes right now that it's just a great potential to build green. So.
Thank you, Matt. I really wait for this implementation idea can be realized soon as possible. So we move to another question from the Q&A, still from Salahuddin. To Pak Wirawan, what is the smallest size for the solar panel in WIPI? Is this a pilot project since you state that it will be finished by 2022?
Thank you, Pak Erwin. As far I know, actually for the pilot of project for this floating PV is in Taman Mini Indonesia Indah or TMII in the PLN Museum. You can see in the lake, man-made lake, there is a floating PV, but the capacity is small, around 5 kilowatt hour. I'm sorry, kilowatt peak means that 5,000 watts, only just few module, PV module. But if you want to go further to the Singapore, there is a proof of concept floating PV. The size is bigger, but 1 megawatt peak is occupied more than 1 hectare areas. But actually right now, we no need to go to the proof of concept because around the world, there is already proven, but means that actually floating PV in terms of technology and also the economic is already proven. So we jump to the real world or the commercial aspect, but no need to go back to the proof of concept. Thank you, Pak Erwin.
Thank you very much, Pak Wirawan, for your very clear answer. I would like to ask question also to Asahi-san. Asahi-san, do you hear my voice?
Yes.
Hello?
Hello?
Hello, I would like to ask a question to Asahi-san.
Mm-hmm. I can hear you.
Okay, are there special materials needed in assuring efficiency of energy transfer process in utilization of heat pump idea?
Special material for
transfer energy from for example, if you want to boil water, use the heat from the air conditioning. Do you need special transfer equipment or special material to transfer the energy?
I think I understand your question, and we don't need special equipment or material to transfer energy or extract energy. But we need a bit of engineering. The engineering is a bit more difficult in industrial application because human beings complain it's hot, it's cold, but they can survive. But for industrial usage, it's directly linked to the quality of products and other productivity of the process. So we need to be a bit careful when we design heat pumps for industrial applications. But I think it's doable. I'm not saying it's impossible, and we don't need special material. Thank you.
Thank you. You mentioned that this equipment also, or this system also can be implemented in the residential level. Could you explain?
Residential?
Yes.
Yes. Heat pumps are already used in residential sector as an air conditioner, or in our country, in Japan, it's sometimes cold, so we need hot water. So we have heat pump hot water heater called EcoCute. And yes, and in your country, it's tropical. It's very hot in your country, and I don't know how much hot water is needed in residential sector. But if hot water is required, then it can be easily supplied by heat pumps.
Actually, we in my home, we also use hot water. We still use hot water.
How do you heat the water?
We have boiler, like a
boiler
for one bedroom, one boiler. Very conventional, actually. So your idea very interesting.
Thank you for your question.
Okay, we have another question for Pak Ray. Pak Ray, I have two questions for you. First, does the system that your company develops must be installed during the construction process of a new building, or can it be installed on an existing building? And the second question is, how to predict the cost required to use the system? For example, the cost required to install the system in a building.
Okay, thank you for the question, Ibu Dewi. And the first question is, it can implement for the new project, of course. We can design from the consultant to actually measure how much the harmonic we want to actually reach. And the second one, if the existing building already use the standard drive, we can replace the low harmonic drive with the same parameters. Then we can reach to suppress the harmonic from the existing system. And the second question about the cost, it's not too far, maybe around 50% higher from the standard drive. But of course, in terms of the transformer, if we compare to upgrading the transformer or the impedance, it consider low if we use another solution.
Okay. Very interesting. Actually, we have one last question from still from Erwin. Actually, the question already answered by Louis, but Louis, can you explain so the other participant can understand the answer from you regarding to
happy to sort of repeat the answer that I gave in the chat. So there were three questions that came in for me. One about whether this is also relevant for mercury waste, which is also apparently a problem in Indonesia. And the truth is that I don't know the answer. I don't know anything about mercury waste and nothing about it in Indonesia. I mean, I guess I know that it's in the CFLs, the new fluorescent light bulbs, but beyond that, no special expertise. Second, there was a question about exporting gas to the US. And maybe I wasn't quite clear, we're not actually exporting any gas to the US. We are processing it, whether destroying or recycling, in Indonesia. And Indonesia has the facilities for destruction and for recycling, not yet, but we intend to build them as we go on, or to work with partners to get them built. And then for three, yes, so we're looking at any air conditioning system of any size. Chillers are very attractive because there's more refrigerant in them, they're larger, it's easier to get them all at once, and we can sort of find them more easily. So yes, definitely looking at chillers, but also at smaller household units, mini splits, and the small technicians who deal with them. So yeah, across the ecosystem, anywhere there's air conditioning or refrigerated shipping or refrigerated trucking, anywhere there's cooling, I'm sure we intend to.
Okay. Thank you very much, Luis, for your explanation. So due to time limitation, we need to finish the session. Thank you very much for to all speakers for the sharing valuable new idea and also innovations, and also, of course, very important information in improving energy efficiency and also the conservation in the building sector. We have very fruitful also discussion in the question and answer section. Thank you also for all attendees who joined this session until now, and I will give the room to the committee. Once again, thank you very much for your all. I hope we can see the idea to be implemented in Indonesia soon as possible widely. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Thank you very much. Bye.
Thank you, Matt, Louis.
Thank you, everyone. Thank you, Bu Dewi.
Bye, everyone.
Bye.
Bye.
See you soon at the other conference.
See you.
Kenapa kita harus berubah?
Indonesia terus bergerak cepat bersama roda ekonomi dunia. Sekarang saatnya beradaptasi, eranya bertransformasi. Tapi, kenapa masih ada yang ragu?
Digital, bukannya ribet ya?
Emang usaha saya bisa diapain lagi pakai digital?
Sinkronisasi data pakai digital. Aman kah?
Untuk terus melesat, jadilah bagian dari perubahan sekarang juga. Saatnya bisnis Anda melesat bersama Telkomsel My Business, partner terpercaya dengan rangkaian solusi digital. Untuk menunjang segala kebutuhan bisnis Anda menuju pencapaian yang lebih baik. Karena sekarang saatnya melesat.
Bank Negara Indonesia bertekad untuk terus maju, bergerak membangun bangsa, dan berkomitmen untuk senantiasa memberikan yang terbaik bagi pemerintah dan masyarakat Indonesia. BNI ikut serta dalam mewujudkan sebuah konsep kota impian masa depan, kota cerdas yang terintegrasi dengan teknologi, mengelola sumber daya secara efektif melalui digitalisasi transaksi untuk meningkatkan kualitas hidup masyarakatnya. BNI sepenuhnya mendukung arahan pemerintah dalam mendorong penerapan program Smart City pada beberapa pemerintahan daerah di Indonesia. Penerapan Smart City pada sebuah kota atau kabupaten memberikan begitu banyak kemudahan dalam bertransaksi, transparansi pemerintahan daerah, dan meningkatkan kualitas pelayanan publik. Dengan jaringan cabang BNI yang luas, channel transaksi online yang beragam, Smart City telah sukses diaplikasikan di sebagian besar pemerintahan daerah di Indonesia. Dengan ikut berpartisipasi dalam mensukseskan program Smart City, BNI telah turut mewujudkan cashless society dalam meningkatkan pelayanan di daerah seperti digitalisasi dan transparansi proses transaksi keuangan pemerintah daerah, memberikan solusi untuk peningkatan penerimaan pajak asli daerah dengan sistem yang terintegrasi dan real-time online, dan meningkatkan kepercayaan publik terhadap transparansi retribusi, penyaluran anggaran, dan pelayanan pemerintah daerah. BNI menghadirkan solusi terbaik yang efektif dan efisien dalam membantu pengelolaan penyaluran anggaran daerah dengan BNI Direct SP2D Online. BNI juga membantu peningkatan pendapatan pajak asli daerah melalui solusi penerimaan pajak daerah serta solusi transaksi cashless lainnya. BNI terus berinovasi dan menyediakan solusi yang sejalan dengan dimensi-dimensi Smart City. Untuk Indonesia, kami selalu ada, dimanapun, kapanpun. BNI, melayani negeri kebanggaan bangsa.
BNI.
It's easy to be blinded by the urgent issues facing our planet. But to shut our eyes is not in our DNA. We look at problems not as one big challenge. We break them down into a spectrum of solutions. Leveraging our pioneering and digital technologies to co-create innovative solutions with our partners and customers across the entire value chain. Powering efficiency by creating a smarter, more flexible power grid. Powering resilience and reliability by digitalizing the energy value chain. Powering safety by enabling cyber-secure infrastructure for mission-critical sectors. Powering sustainability by integrating renewables into the power grid. We are two pioneers combining generations of expertise for a stronger, smarter, and greener future. Powering good for sustainable energy. Hitachi ABB Power Grids.
Siap, ya. Ini saya jalan ya.
Pak, tunggu, ini ada yang belum, Pak. Pak, ada tagihan pajak.
Oke.
Pak, gaji karyawan harus diotorisasi.
Beres.
Halo Pak, pembayaran supplier harus segera jalan ya Pak.
Oke. Gampang.
Lakukan semua transaksi harian perusahaan Anda. Anda dapat dengan mudah mengelola transfer management, billing payment, electricity payment, dan lainnya. Dengan BNI Direct Mobile, Anda dapat mengelola bisnis Anda 24 jam, kapanpun, dimanapun. Semua urusan jadi lebih mudah. Download BNI Direct Mobile.
BNI.
Sekarang semua serba listrik, masak juga. Karena kita kan pakai kompor induksi, bentuknya keren, modern, terlihat canggih. Ini tidak ada apinya. Anak-anak bisa aman masak pakai kompor ini. Padahal pancinya panas loh.
Hidup sendirian itu butuhlah yang praktis-praktis.
Kayak kompor ini, mudah dibersihkan, mudah digunakan. Tinggal pencet, nyaman, bisa dipindah-pindah. Jadi bisa cari posisi enak untuk masak hotpot. Dan video callan deh biar seru.
Kompor induksi itu suhunya dapat diatur sesuai kebutuhan masak dan stabil. Jadi bisa lebih cepat. Pelanggan gak perlu nunggu lama dan kita bisa melayani lebih banyak. Omset pun jadi naik. Yang jelas, kompor induksi itu tidak ada emisi CO2, berarti ramah lingkungan. Karena dengan listrik, hidup lebih baik.
Kita baru saja menang tender. Siapkan bank garansi untuk jaminan pekerjaannya.
Oke, saatnya ke bank. List segala persyaratan, pastikan semua dokumen lengkap.
Tolong semua dipercepat ya.
Untuk itu, gue diandalkan.
Loh, tanda tangannya mana?
Aku lupa tanda tangannya ibu. Bu, maaf.
Makanya pakai bank garansi. Langsung buka di gb-online.bni.co.id. Isi application, lanjut approve, release, data submit deh. Semua sudah tahu bank garansi kan?